In question 1, we have to find the unit that is equivalent to what? That is the unit of power. And what is the unit of power? Power is equals to energy divided by time. The unit of energy is joules, and the unit of time is seconds. So we know the unit of power is watt. So you can basically write 1 watt is equals to 1 joule per second. So the answer is D. In question 2, we have to select two vector quantities. So if you see option A, it is acceleration and weight. Acceleration is a vector quantity and weight is a force. And any sort of force is a vector quantity. So the answer is A. But option B, displacement is a vector quantity, but energy, kinetic energy, is a scalar quantity. And we have to remember, any sort of energy is a scalar quantity. Option C talks about strain and velocity. Strain is simply change in length by original length. So strain is a scalar quantity and velocity is a vector quantity. Option D talks about Young's modulus and mass. Young's modulus is a material property of a substance. Young's modulus is a scalar quantity and mass is also a scalar quantity. So the answer is option A. In question 3, they're telling us to find the average velocity of the person through the graph. So what is the formula of average velocity of a person, or the average velocity? The formula for average velocity is total displacement divided by total time. So the average velocity is total displacement divided by total time. So from the graph, we can see the total displacement of the person is 40 kilometers, and the total time he took is 4 hours. So you simply have to do 40 over 4. So you will get 10 kilometers per hour. And we also have to remember the gradient of displacement time graph gives velocity. So any option that will be stating about area is out of the correct answer region, as you just have to figure out the gradient of the graph. Option that talks about area between the curve, no, this is not the correct answer. So gradient and tangent, no, as you're talking about average velocity, we have to get the displacement traveled in the total displacement traveled in 4 hours. So the answer is D. Question 4 is telling us to find the Newton's third law pair force for the weight of the cable car. That is the question. You simply have to find the pair force of Newton's third law for the weight of the cable car. So at first you have to understand from where the weight is coming from. The weight is actually coming from Earth, right? So the cable car is getting a weight because of the gravitational force of the Earth. So you simply have to find its Newton's third law. So whenever talking about a cable car and Earth, so simply the Earth is pulling the cable car downwards by gravitational force. Hence, the cable car will be pulling the Earth upwards by gravitational force. And for Newton's third law to occur, you have to choose the exact same type of force. Air resistance is actually not weight or gravitational force. B, in option B, you can see gravitational pull of the cable car on the Earth. And this is the correct answer, as gravitational force is the same type of force, which is weight of the cable car. Option 5, it is saying a box is sliding down a slope at a constant speed. So if you're talking about this, this is a slope, and the box has been sliding down like this, and it is falling at a constant speed, which means this force F1 and the force F2 needs to be balanced. And force F2 is actually resistive force or resistive forces, and F1 is the component of weight. If this is theta, This is also theta, so you will get W cos theta, and this is W sine theta. So for the box to fall at a constant speed, the component of weight needs to be equal to all the resistive forces acting on it. So let's see the options that we have. The component of weight parallel to the slope is equal to sum of the resistive forces. Yes, so this is the answer. Why is B not an answer? The component of weight parallel, no. If the component of weight is greater than the resistive forces, there will be a resulting force. Hence, the box will accelerate. But we have to find the scenario where the box is moving at constant speed. All right. And what is the word parallel meaning over here? Is this component we're talking about. The component of perpendicular is whenever they're talking about the perpendicular component, they're talking about W cos theta, and W cos theta and the resistive forces are not acting in the same line of action. So the options that are talking about perpendicular to the slope are already out. We just have to choose parallel component of the slope, the parallel component of weight to the slope. In question 6, you have to find the efficiency. So the formula of efficiency is power output divided by power input. So we know already the efficiency is 0.63. So you put it here, 0.63. Now from the question, you have to understand which one is actually the power output and which one is the power input. So if you're seeing the question, it is about a person standing on a moving staircase, and the staircase is giving an energy of 5,000 joules in a time of 42 seconds to the person. So we know the power output of the staircase. Now we have to find the power input, it is stated in the question. So if you want to find power output, but the information that is given is in energy and time. As we know, power equals to energy over time. So you can simply write 5,000 divided by 42, and we can write power n. So if you give subject to power n, that is 5,000 over 42 divided by 0.63. So you will get 5,000 divided by 42 into 0.63. And the option is C. So the summary of this question is they're telling you to find the power input of the moving staircase, but the information that is given, it's in energy and time. So you have to understand the formula of power is energy over time, and from that you have to find power and do all the other things. In question 7, they're telling us to they're asking us to describe the wire at the elastic limit. So we have to understand what is till elastic limit. What happens to the wire till elastic limit? So till elastic limit, the wire obeys Hooke's law. And Hooke's law is specifically saying force directly proportional to extension or change in length. So the more the force that you give, the more will be the extension. And the relationship between both the quantities is directly proportional. If you cross the elastic limit, the object will not come back to its initial position or shape. So till elastic limit, the object is going to return to its initial position or shape if you remove the force from the system. And that sort of deformation is actually elastic deformation. So our answer is A. If the wire had crossed the elastic limit, the deformation that we're talking about will be plastic. But this is not the case here. In question 8, a student uses a wooden bat to hit a stationary ball M. So when the mass of the ball is M, the decrease in momentum of the bat is change in B, and the velocity of the ball is V. But when the mass of the ball is 3m, the decrease in momentum of the bat is 2 into change in momentum. Now we are asked to find the velocity of the ball. So for you to solve this question, you specifically have to understand the formula of change in momentum, that is mv minus mu. And now this change in momentum is the change in momentum of the ball as we're trying to find its velocity. All right. So now we have to understand the ball was initially stationary and cu is equals to 0 meters per second. So the formula of change in momentum boils down to mv. So all the changes that are taking place is responsible for the final velocity. So if you give final velocity to the subject, that is change in momentum by mass. Now the change in momentum increased by a factor of 2. The change in momentum increased by a factor of 2, hence the velocity of the ball will increase by a factor of 2. The mass of the ball increased by a factor of 3, hence the velocity of the ball will decrease by a factor of 3. So the overall answer will be 2 by 3v, and the answer is B. Why are we doing this here? As velocity is directly proportional to change in momentum, and velocity is inversely proportional to m. As momentum increased by a factor of 2, velocity will increase by a factor of 2, and as mass increased by a factor of 3, velocity will decrease by a factor of 3. Hence the answer is this. In question 9, we're asked to find the expression that gives the forward component of the total force of the boat on the ship. So there are two boats A and B. Two boats are pulling the ship. So if we say this is FA and this is FB, we simply have to resolve the forces as the total force in this direction. So for this, for FA, you will get FA cos 31 plus you will get FB cos 27. So this overall force is actually the forward force. And this is simply found by resolving as this is with the angle. So this component, the horizontal component will be cos, and for this also the horizontal component will be cos, for which the answer is C. Question 10 is talking about the moment. Question 10 is talking about moment. So we have to understand when the foot is horizontal in equilibrium. So when it is in equilibrium, you simply have to know that clockwise moment is equals to anti-clockwise moment. This is the clockwise moment, this is anti-clockwise moment. When something is in equilibrium, the net forces active on it is 0, and the net moment active on it is also 0. So if you solve it, if you consider this to be the pivot, or this point to be the pivot, so we have clockwise moment equals to anti-clockwise moment. So this is the clockwise moment, which is W minus F into Y, that is equals to Fx. So we have to simply find weight, that is W. So W minus F is equals to Fx over Y. Therefore, W is equals to Fx over Y plus F. So the answer is A. We simply wrote clockwise moment equals anti-clockwise moment, and we use these values and subtracted W from it.